Hello and welcome back to part 2 of this video tutorial on using Privacy International's Data Interception Environment. I'm Christopher Weatherhead, Technology Lead at Privacy International. If you haven't already watched part 1, I would suggest you watch part 1 and getting the Data Interception Environment set up. In part 2, we will look at intercepting a virtual phone running Android 8.1. This video is a continuation of part 1, so if you haven't watched part 1, I would go back and watch it now. I'm going to continue from where we left off in part 1 by starting the data interception environment in VirtualBox. We're going to start MITM proxy. And we're going to start the phone in Genymotion. So we'll open Google Chrome. And go to mitm.it. And we'll download the certificate. Once the certificate is downloaded, it will appear in the download section of the Files app. I'm now going to start my local terminal so I can install the certificates into the system root store as outlined in the documentation on the GitHub and inside the data interception environment. First I'm going to do ADB devices to see what devices I have enabled. There is only one device available, which is the Genymotion device. I'm going to start ADB shell, which allows me to access the local console of the Genymotion phone. If I change the directory to SD cards download and list the directory, we can see the MITM proxy cert listed there. Go back to the instructions and execute the commands. We can close MITM proxy for the time being because we don't need it. We can also open the documentation locally. Let's copy this, and in the VM running the data interception environment, we will open the console. We'll copy and paste the OpenSSL command into the local console on the VM running the data interception environment. We get the output C8750F0D, which is the name we will have to give the certificate later when we copy it into the system root store on the Genymotion device. Returning back to our local console, which is still running ADB shell. From the documentation, I'm going to copy this mount command so I can copy and paste it into the local console in just a moment. First, we're going to execute su to become super user on the device, i.e. the local administrator. Next, we're going to remount the partition for the system folder. This allows us to modify system data, which is usually read-only. Now we're going to copy from the downloads folder the certificate into the system's certificates folder. When copying the file, we need to use the name we retrieved earlier from running the OpenSSL command. So we will call it C8750F0D. And the important bit is that the extension is .0. We need now to change the file permissions. So we'll copy this one into the local console. And again, type in our certificate's name. You can use autocomplete, use a tab to autocomplete for. We also need to change who the file belongs to and make sure it's belongs to root. With those steps done, we're able to remount the file system read-only. And we can then reboot the device. We no longer need this console, so we can just exit it. And we can restart MITM proxy. As you can see on the left, the device is now rebooting. We'll open MITM proxy in the web browser. As you can already see, there's a large amount of data that's being collected. This is because as the device boots up, it checks for internet access. If we now look at the Wi-Fi settings, unlike previously where it said connected, no internet, it now just says connected. We'll open Google Chrome, and we can just do a quick check that MITM proxy is installed correctly. I'll go to Privacy International's own website. If we scroll through the list of things being intercepted by MITM proxy, we'll be able to see that these are all the requests being made to PI's website. If we click on the status bar, we can see that the certificate being presented to Chrome is that of MITM proxy. And if we look at the certificate information, we can see that the issuer is MITM proxy. Just for the sake of completeness, we'll go to Privacy International's website in a browser that isn't being intercepted. And again, look at the certificate information. And as we can see, the certificate is usually issued by DigiCert Inc. If you look at the certificate, it even includes all the information about PI. With that done, we'll close Chrome for now. We can also close all the other applications we had open, as we don't need any of those at the moment. If we open the Settings app and do a search for certificates and look at the Trusted Credentials section, which displays the trusted CAs, and click on the System section, we can scroll down and see the MITM proxy as a trusted system root. We're going to close MITM proxy just for a moment and start a new session. Every time MITM proxy is restarted, the previous capture is saved to disk. And we'll restart MITM proxy and head back to the MITM proxy's web page. As you can see, the capture area is now clear as a new capture has been started. I would recommend always starting a new capture with every different application you wish to test. With that said, let's start by looking at the Met Office app by launching it on the Genymotion phone. Almost immediately when opening the Met Office app, you can see that it's making a number of connections to various web services. A lot of them appear to be Amazon Web Services. And this is before we've even accepted their privacy policy. If we click on requests, we can see what the original request was and what the response is. For example, this is Google Firebase, and we can see what token was used to authenticate with and what response was given for that Firebase installation. As you can see in the bottom right-hand corner, you can also find out information such as the SDK version of this version of Firebase Analytics. You can also see downloaded imagery such as that displayed in the top portion of the Met Office app. In this case, the Met Office logo. As you can see, as soon as we accept the privacy notice, again, lots of different connections are being made. Obviously, some of these will be content, others of them will be measurements, metrics, advertising, or other third-party services. As you can see from the list of things, there's a lot there, including quite a lot going to ad systems and DoubleClick, which is Google's advertising service. Again, you can see what features are being passed back to Firebase by looking in the content of the messages being exchanged with MITM proxy. So I'm going to close the Met Office app and we'll do a new capture on Truecaller. Oop, didn't mean to do that. As I said previously, all captures are stored locally in Privacy's home folder, so the most recent captures can all be reloaded. If we start a new empty session of MITM proxy, we can use it to open a previous session if we want to look at that data again. For example, here's all the data we've just collected from the Met Office app. Should we wish to read it back at a later date or reanalyze it? We will now run MITM proxy again, get another fresh instance, and do an analysis of the Truecaller app. So we're going to open Truecaller. As you can see, the first things it is already making requests to Firebase before we've even done anything within the app. It's interesting to see what different options do when you click them. So this app has sent data to Facebook, and we can see that because it's going to the request is made to graph.facebook.com. As you can see, there's quite a lot of data being exchanged about various aspects. This, which is another message to Facebook, which is trying to reconnect your Facebook profile with the app if you have Facebook installed on your handset. If we look at this graph.facebook message, we can see that this is quite a standard message sent by Facebook's SDK. You can see there's quite a lot of information you can glean from this message, including the event that's being sent to Facebook, along with information about the device, the phone, the application, the advertising ID. All of these sort of bits of information can be cross-referenced by Facebook to create profiling. I said in my part one of the new features of the Data Interception Environment is the inclusion of Apk Mitm. This allows the removal of certificate pins. Some large apps like Facebook, banking apps, Twitter, and some of the other apps that have large numbers of users use a technique called certificate pinning, which means that they expect a certain certificate to be presented by the remote side when making a connection, and if the certificate differs, then they will not make that secure connection. What Apk Mitm allows is the removal of those pins so you can continue to do analysis in the data interception environment. Cheers! Privacy International is a human rights organisation based in London, United Kingdom. We're a registered charity. If you find any of our outputs useful, you might want to consider donating to us. You can do this at action.privacyinternational.org/donate.